evening, and first, a very happy new year to you all. Well, 2010 ended with something interesting, an eclipse of the moon. Not many people saw it, but something was seen from South TV. Pete Lawrence got some pictures.
The eclipse has definitely started. There's a definite edge darkening on the left-hand side of the moon. This is really getting quite exciting now.
More about that later. Now, volcanoes. It's been said, that volcanoes are the Earth's safety valves. In a way, that's true, but when one goes off, it's not a good idea to be too close to one. Well, remember, our Earth is not the only world to have volcanoes. There are others. Within one of my oldest friends, Peter Catamole. He is a volcanologist, and volcanoes attract Peter as a jam jar attracts wasps. Welcome back, Peter.
Thank you.
First of all, why have we on Earth got these very active volcanoes and other worlds don't seem to have them in the same way?
The Earth is unique in one way, in that our planet recycles its surface more or less continually. I know we'll find Io does that too, but in a very different way. Earth seems to retain enough heat and enough water to allow the inside of our planet to have convected for a very, very long period of time. Right from the beginning of the Earth's history, possibly 4,000 million years ago, it's convected, continually recycling the surface. And that constantly brings heat and gas towards the surface. And so our volcanoes have been active right from the very beginning of time for the Earth, and will continue to do so, I'm sure, for roughly the same length of time.
Peter, not everyone's going to know just how a volcano works.
The molten lava that fuels any volcano has to get to the surface. And rather like the gas in a champagne bottle that's under pressure until you take the cork off and enjoy the champagne, so the gas that's trapped in the lava beneath the Earth's surface has somehow to escape. So the first thing you have to do is find a weakness, so the lava can come up, the gas can expand, and you have this huge eruption cloud. This is exactly what happened in Iceland. Iceland is probably one of the most volcanically active regions of the world, because it sits on a line where, believe it or not, the Atlantic Ocean is splitting apart. A new ocean floor is forming. And most of the ocean floor is made of the rock basalt. And it is this rock basalt we have a piece of here that we've found is the most common volcanic rock in the entire solar system.
And that bit came from Iceland?
This bit actually came from Iceland. I think you collected it.
I did.
And so you see enormous amounts of basalt on the ocean floor. You see enormous amounts of basalt on all of the terrestrial planets. It's one of the fundamental components of what planets are made of.
Now, what about this ring of fire, Peter?
Well, yes, I mean, Mount Everest sits on this ring of fire. And if you look at a map as we have here of the Earth, you look around the Pacific Ocean, and shown in a coloured band, you'll see what's called the Ring of Fire. Well, around the margins of the Pacific, one of these plates is diving down beneath on the west, the continent of Asia, and on the east, under North and South America, plunging down, generating very, very explosive eruptions. So we call it the Ring of Fire because that's what it is. And that zone is more or less continuously active and very, very dangerous.
There are other kinds of volcanoes too.
Well, of course, if you go to the middle of the Pacific, we have the Hawaiian Islands, which sit in the middle of one of these huge slabs and are generated in a totally different way. We think that these sit above what we call hot spots in the Earth's mantle layer, sort of unusually hot masses of rock that are constantly moving towards the surface and producing melting of the near surface layers of the Earth. And the volcano Kilauea is a typical, what we call a shield volcano. And it's interesting you should mention them so early on, because it's shield volcanoes that are typical of Mars and of Venus as well.
So Earth is continuously active. So let's look now, shall we, Peter, at one or two other worlds. Beginning, of course, with the red planet Mars.
Yes.
And we have plenty of them there.
When you look at a map of Mars, as we now have from spacecraft, there are two huge bulges in the Martian crust, one called Tharsis and one called Elysium. And interestingly, most of the big volcanoes of Mars are concentrated on these huge two sort of lumps in the Martian planet.
I remember looking at Mars through my telescope a long time ago, just after the war, I think. There I saw Tharsis all right, but I don't know what it was.
Well, nobody did, of course, until Mariner went there, and then subsequent spacecraft showed us we had these huge volcanic structures. I mean, Olympus Mons is probably, didn't it used to be called Nix Olympica, if I remember, on the old maps?
The Olympic snow.
The Olympic snow, because there was cloud on the top,
Yeah.
which you often saw as a white, like a snow-like shroud. Turned out to be a vast shield volcano.
3 times as high as Everest.
3 times as high as Everest, about 10 times as big as anything we have in Hawaii. And it wasn't alone, because on the same bulge there were 3 other huge volcanoes, Ascraeus, Asia and Pavonis Mons, and they all have one thing in common. They have at their summits these huge depressions called calderas, and that's exactly what happens in Hawaii too.
Now, Peter, those were very active a long time ago. Do you think they'll ever be active again, or is there any activity there now?
There have been some recent results from one of the recent craft using isotope data that suggests possibly there has been some recent activity, but these results are open to different interpretations. My own suspicion is I think that activity is now all over and that Mars is a dead world.
Well, we'll find out finally when somebody actually goes there. I wonder. So, Peter, let's come now to a world that is definitely not dead. And that, of course, is Venus, our twin. We know that Venus is, or was, a highly volcanic world, but is there any activity going on there now? I think there probably is, you know.
We have certainly had some recent data from the Express spacecraft suggesting that there might have been some very young rocks formed at the summit of 3 of the shield volcanoes, and the suggestion has been made by a group of American scientists that this suggests there are recent smooth volcanic rocks to be found on the summits of some of these shields. But I have to say that that is only one possible interpretation. There may well be others. It may have nothing to do with that. When describing Venus these days, we usually show radar maps, and what radar images are, they're representations of the roughness of the surface. And radar does 2 things. It can image the roughness or smoothness of a surface. Smooth surfaces tend to be dark, and on this map the dark low surfaces are shown in shades of blue, and the rough high surfaces are shown in the light colours, the yellows and the reds.
Bear in mind, blue does not indicate sea.
Blue certainly does not indicate sea. If Venus ever had seas, and I suspect it never did, they went off very early in its history. But you do see there are rough highland areas and smooth lowland areas quite clearly on these images. But certainly it's worth remembering that Venus has resurfaced itself numerous times during its long geological history. The most recent, we believe, was 300 million years ago, and then prior to that, many hundreds of millions of years before. So if there has been a big hiatus in its volcanic activity, then perhaps it's building up for another resurfacing event as we speak. It would be very exciting if it was, but nevertheless, I have to say I remain a sceptic. I don't think there's very much happening there now.
It's going to be very hard to find out.
Well, it is. We have to send another radar spacecraft there to see, and you'd have to be extremely lucky to actually see an eruption taking place while you were there.
The other inner planet is Mercury.
Yes, well, of course, we've had some very nice images recently from the Messenger mission. We know that large areas of Mercury now are actually covered in plains which we know to be basaltic. They are volcanic, and you can see lava flows in places. But also on some of the higher resolution images, we now believe we can actually see individual volcanoes. There's one here. You can see the top of the image, it's a rather smooth area with a central depression, which may be something like a small terrestrial shield. But we'll have to wait for future images to know how frequently these are to be found.
Certainly all activity there ended long ago.
I believe so, many millions of years ago, I suspect.
And we come now to Jupiter and its moons, and there we have Io, the most volcanic world in the entire solar system, a world just a bit bigger than our moon, going around Jupiter, of course, and a very strange place.
When the early spacecraft went out and they started imaging Io, they found these amazing plumes rising from the disk of Io, and it was suddenly realised that these were huge plumes of volcanic material. And once we'd seen one, we began to see that the whole of Io seems to be active more or less continuously.
Well, from Earth, you see Io as a tiny speck. I mean,
Well,
any small telescope will show it.
Well, that's right. And it's believed that Io resurfaces its whole surface in probably less than 1 million years with what appears to be sulphur.
Well, I don't know, is there anything similar here?
If you go to a volcanic area like Java,
Yeah.
you certainly can see little sulphur volcanoes, but on a very much smaller scale. There's one here of Kawa Mas in central Java that I've visited many times, and that does produce little sulphur flows, the longest of which is probably about 7 metres long.
Yes.
So we're talking about a totally different style of volcanism, because on Io we have calderas. Big calderas, and indeed on some of the images that we've had back, you can see that within the space of 2 or 3 months there have been quite considerable changes taking place on individual volcanoes.
Activity going on there all the time.
Activity going on all the time, as you say, the most actively volcanic world in the entire solar system.
Right, going on now to Neptune and the satellite Triton. But it's nothing like our own volcanoes.
Without a shadow of a doubt, now that we have some quite high resolution images of Triton, there are very dark areas, rather irregular, and we believe these are actually active geysers, which are arising through fractures in the silicate and ice surface of Triton, and that they're possibly, it's quite a commonly active world where this is happening most of the time.
The discovery of activity out there was one of the most startling things we found yet.
Yes, I believe so. We just weren't expecting any of it. I mean, sulphur volcanoes on Io, geysers on Triton, whatever. A science fiction writer have written that story, and yet it's reality.
Peter, thank you so much.
My pleasure, Patrick.
Well, we can see volcanic features on the moon, and Pete and Paul are outside with my telescope to say a bit more about them.
Is that about right, Paul?
Yes, keep going.
Okay.
Put some effort into it.
There's a fantastic first quarter moon out there, you know.
Yes, and it's remarkable what you can see with just the naked eye at first quarter, isn't it?
It is. I mean, you've got the dark features, which are known as maria, or seas.
Which, of course, quite a misnomer because they're completely dry. And the craters as well, some big craters visible to the naked eye. And the maria are interesting things, aren't they? Because we're talking about geology and the volcanoes of the solar system. They're a strange thing, really, aren't they?
They're a bit of a hybrid event, really, because they're caused by an impact event and volcanism. I mean, it's thought that some large body impacted on the moon, created a huge basin, and the collision was so violent that it actually cracked the lunar crust, and lava came out of the cracks which formed and
flooded the whole
filled in
basin.
the basin. So you've got this lovely smooth appearance to the basin.
And I think this month we're going to look at some interesting volcanism regions on the moon, and we have here, look what I found, a wonderful lunar map from Patrick's study.
Now, I have a problem with this straight away because, I mean, Patrick loved it this way around.
I liked it as well.
But this is what you look at if you look through a telescope.
Absolutely.
So we turn it around the other way so we can just describe where these things are.
Yes, it's upside down, isn't
Okay,
it? There we go. If we can just turn this round.
It's quite a big map.
It is. It's a lovely map. So
what are we going to be looking for?
Okay, so we're going to be looking for domes. These are very interesting things. They're sort of like upwellings that have come up from the surface. It looks like something's pushed the surface up locally but not broken around it.
Right.
And they tend to occur all over the moon but in clusters.
Right.
So we have here a nice lunar map. We can show where some of the most interesting ones are.
Okay, yeah.
So if we go to the crater Milesius, this is very easy to find, look, because it's almost halfway between crater Copernicus and
yes.
Kepler. And just to the west here, there's another nice little collection of domes, which are sort of, again, easily visible in a small to medium-sized power telescope.
When would you see those?
Okay, so the best time, you get 2 shots again, 3 days after first quarter, 2 days after last quarter.
Okay, right. That's quite a good location, actually, because there's another nice crater quite close by. Now, I'm not going to stick with just one dome this time. I'm going to go for a whole field of domes.
You're just a show off.
Now, if you find Copernicus is a very obvious crater.
It
It's got
is,
loads
yeah.
of lovely rays coming out
beautiful.
of it. But if you go down south of Copernicus, there's another smaller but quite well-defined crater called Reinhold. Now, if you go halfway between Reinhold and Miliacus, there's a small crater called Hortensius.
Right.
Now, just to the north of that, there's a lovely dome field called the Hortensius Domes.
I see.
Now, if you look at those with a fairly large telescope and you get the lighting right, similar sort of time to Miliacus, if you get the lighting right, you can see these beautiful curving domes. Now, if you're into imaging and you can get a high-resolution image of this area, you can pick up that each of those domes actually has a little pit in the top of it.
Oh, lovely.
Apart from one, which has no pit,
Right.
and apart from another one, which has 2 pits.
Right.
Now, those pits are a bit odd because they're not like the normal caldera you'd get in the top of a volcano.
No, they're not. And Kuiper had the idea that these may have been been extinct volcanoes. I
Right.
don't think anyone's still really sure what these
No,
things
they're a
are.
bit strange, aren't they? They're probably associated with the form. Well, obviously they are the formation, but why one should have no points
It's
and the other
very,
should have
very
two is very
strange.
peculiar.
Well, Pete, there's some lovely geological features there on the moon for people with any size telescope to look at.
Absolutely right. And talking of the moon, we had a very interesting lunar eclipse about a week or so ago, and it was a lunar eclipse that kept us guessing right up until the last moment. It's a bitterly cold December the 21st morning. It's about 6:15 at the moment, and I'm anticipating the start of one of nature's finest events, a total eclipse of the moon. Now, as total eclipses of the moon go, this one is quite a special one because it coincides with the winter solstice, the date on which we get the shortest amount of daylight as seen from the UK. Now, the last time that happened was about 400 years ago, so they don't come around that often. Now, this particular total eclipse is going to be quite a challenging one to capture photographically, because as the moon goes into eclipse, it will also be setting. In fact, it sets when the moon is totally eclipsed. That coincides with the sun coming up in the east as well, so it is going to be quite a tricky one to capture in the camera. Now, a total eclipse of the moon occurs when the moon moves into the Earth's shadow in space. Now, the Earth's shadow has two components to it. It has a fainter outer ring, which is called the penumbral shadow, and a darker inner ring, which is called the umbral shadow. Now, how dark the umbral shadow is depends on what there is in the Earth's atmosphere, because as the sun's light hits the Earth's atmosphere, some of it gets bent or refracted in, and it infills the Earth's shadow. The darkness depends on what's been going on the Earth itself. And we have had some volcanic eruptions like the one in Iceland, so it'll be interesting to see just how dark this particular eclipse goes. Well, it's just after 6:30 and the eclipse has definitely started. There's a definite edge darkening on the left-hand side of the moon. It's quite a fantastic sight here. We've got the reflection of the moon on the sea and the sky is perfectly clear. This is really getting quite exciting now. But the eclipse is really well underway now. We're very, very close to totality. In fact, it's getting very difficult to actually see much of the moon. This does look like it's going to be quite a dark eclipse. There's a little slither of moonlight left, and in the next 10 minutes or so, the moon will be totally covered by the Earth's shadow. Totality has happened, and for me at least, the moon has gone very, very dark. I'm not entirely sure whether it is just totality or whether the moon has moved into a fog bank close to the horizon. Hopefully someone further to the west of me will be getting more luck and they'll see the moon in totality higher up. Now, it was definitely reddish in colour. Now, recently we've had some volcanic activity, such as the volcano in Iceland, so that could well be affecting the darkness and the colour of this totality. Well, that's it. The moon's disappeared. I'm actually quite astonished. I wasn't expecting it to just disappear completely from sight, but I can't see it at all. It's been quite an incredible eclipse. I'm very lucky. I've got some great pictures, and hopefully other people will have some too.
Well, Pete, that was a wonderful eclipse, wasn't it?
We were really lucky with the weather.
There we were, and they don't come like that very often.
No, they don't.
And even better, we have plenty of good stuff to look at this month. And staying with the moon, we have an interesting crater.
Ah, yes, the crater Hermite is a very interesting crater. It looks to us quite elliptical because we see it virtually edge on.
Yes.
It's in the zone of libration, so that as the moon rocks and rolls, sometimes we get to see it, sometimes we don't get to see it.
And that's called a libration.
That's
and,
right.
And in February, this will be placed, the libration will place this crater onto the disk.
That's right, it's sort of in the northern edge, on the northwestern edge of the moon. The crater will rotate into view and will be quite well placed, sort of between the 17th and the 20th of February. So if you go out and you can see the moon at this time, point your telescope to that area of the moon, see if you can see this large elliptical crater.
It's quite a lovely crater as well, isn't it?
It's an interesting crater actually because it's got some nice dark shadows inside it, and in
Yes.
fact it is so positioned that it never actually catches the sun's rays at all.
Good heavens, it must be very cold.
In fact, it's the coldest recorded place in the solar system system, which is amazing. It's about minus 249 degrees centigrade.
And so close to home as well. Remarkable. Of course, that's not the only thing returning now, is it? We have returning into the morning sky the planet Saturn.
Yes, Saturn. I mean, Saturn is one of my favourite planets. There's only 8 of them, I know, but I can't pick.
It is stunning.
But Saturn's the first planet I ever looked at properly through a telescope.
Yes.
A tiny 40mm telescope, and it knocked my socks off.
Even then, you'll see the rings if they're wide open,
Yeah.
the satellites. One of the things we've noticed at the moment is there seems to be a bright white spot on the planet. So every now and then, Saturn does flare up these enormous bright white spots, and they are fascinating to watch, because if you time them, you can get an indication of how quickly that part of the planet is rotating. So yes, certainly well worth amateurs to go out there, take pictures of drawings, be a useful thing to do.
Now, talking of bright things, if you go out in the early morning and you look towards the southeast, towards the south, there is a really intensely bright
It's
planet
unmistakable.
on view, which is Venus.
And quite unmistakable,
In fact,
isn't
it's
it?
called the morning star. It's not a star at all, it's a
No,
planet,
no.
but that'll do because it looks absolutely stunning.
And binoculars or a small telescope will show the phases, rather like the moon, as it moves through its orbit, won't it?
That's right, because it orbits closer to the sun than we do. We don't see it fully illuminated unless it's on the very far side of the sun when it's too close to the sun to see.
That's right.
But then as it moves around its orbit, we actually see different parts of it illuminated. So it's, although half of it is illuminated, we see that from different aspects. So we get to see it in crescent form, half Venus and gibbous phase.
That's right. And it's at the greatest western elongation as well very soon, isn't it?
That's right, on the 8th of January. So that should theoretically be where we see it as actually a half planet, so a half a circle.
Well, there's some lovely things to look at this year, Pete, but at the end of last year we had something rather nice too, didn't we? The Geminid meteor shower.
Yeah, that's one of my favourite meteor showers of the entire year.
Well, here we are on the night of the Geminids, and it's a fantastic clear sky in Selsey, and I'm here with Damien Peach. It's been good, hasn't it, Damien?
It's been very, very impressive so far. Conditions are slightly hazy tonight, but we have been fortunate to see quite a few meteors so far.
It's been lovely, hasn't it? This is the best way of observing meteors, but you're trying to photograph them, aren't you, Pete?
I am. I'm doing sort of quite short exposures with the camera set to high sensitivity and just repeating the shots over and over again. The arduous bit about that, of course, is that you then have to sit down and work through every picture to see if there's a meteor trail on it. Can be quite exciting, though.
Yes.
The Geminids are a very interesting shower, of course, because meteor showers occur when the Earth passes through the debris left in the orbit of comets, because comets are very dusty, or they're like dirty snowballs, the best way of describing them. So as the comet heats up as it goes close to the sun,
Throws all this material off.
it throws all this material off and it leaves a load of debris behind it, a load of dust behind it.
That's what we pass into, isn't it, as
And
we go around?
when the Earth goes through the comet's orbit, it passes through that debris stream, and because all these objects, all these little tiny particles, which are known as meteoroids, are basically in parallel as they hit the Earth, it looks from our perspective as if they're all coming out from a point in the sky, which is known as the meteor radiant. The way of telling whether a meteor belongs to the Geminid meteor
Oh, you've got
stream,
your lovely little trick, haven't you?
well, there are lots of different things that actually have to fall into place. First of all, it has to appear to be coming from the direction of the radiant. And for the Geminids, the radiant is just to the north of the star Castor in Gemini. So that's the first thing. The second thing is the length. Meteors which occur very close to the radiant tend to be very short if they belong to that shower, and they tend to be very long if they're away from the radiant.
Right.
So if you see a long meteor very close to the radiant, that's probably not a Geminid, even if it's in the right direction.
It's just a sporadic, isn't
And
it?
if you see a short one, long way away, that's probably not a Geminid either.
So one just passed through a very, very short tail.
Yeah, that was a really nice one.
But what's interesting about the Geminids is that the parent body of the shower
Oh, yes.
is not thought to be a comet. It's actually an asteroid.
What, it's Phaethon, is it? Is
It's-
that how it's pronounced?
3,200 Phaethon is the actual name of this asteroid.
Do you do much photography of meteors, Damien?
It's not an area that I've a great deal of expertise
No.
in.
I have tried it a few times, but I got some nice star trails, but no meteors.
Yes, I think it's something that requires a great deal of patience.
Yes.
Oh, it does.
Yeah, it's not some, no, I've never bothered with it.
Do you know what it's like? It's like celestial fishing. That's how I've always liked
You
it.
heard it here first. Meteor is celestial fishing.
It's very much a statistical thing because you never really know where they're going to occur. People often say, where do you look to see a meteor from a meteor shower? And probably the worst place to look would be directly at the radiant.
Like we're doing now.
Like we're doing now, because then the meteors will be pretty short. If you look sort of away 60 degrees either side of the radiant, then you're likely to see quite long, nice meteors when they occur.
Yeah, even during the lulls of the meteor shower, you can still enjoy the dramatic beauty of the winter sky.
You can. Look at that. That was quite a bright one, wasn't it, that went down? And you saw it, Damien.
Yeah, that certainly was. Perhaps the brightest one I've seen tonight. It's
really lit up the clouds, didn't it?
It certainly did, yes. And it's just a shame that it wasn't higher in the sky, or it was a bit clearer in that direction. Otherwise, that would have been really quite dramatic.
Yeah.
That's pretty typical of meteors, actually, isn't it? If you get a really bright one, it's either down very close to the horizon or just behind a tree.
Or hidden by clouds.
Well, so much for this year's Geminids. Pete and Paul, thank you very much. Now, indoors with Chris, news notes. Let's begin, shall we, with Akatsuki, the Japanese probe that sadly has missed Venus.
Yes, it was meant to go into orbit around Venus in early December last year, and unfortunately there was a problem with its engines. Investigation's still going as to the cause of it, but it missed Venus. It swung round. It took some images on the way out, so there must have been very solemn-looking people seeing these images coming back.
And they're still in touch.
They are still in touch. The spacecraft is healthy. The scientific instruments are perfectly healthy.
And there could be another chance.
Yes, and all is not lost yet. In 6 years, it could manage to go into orbit around Venus. So we'll just have to hope that they manage to pull off that manoeuvre in 6 years' time.
And also, there's E. Merlin.
Yes, E. Merlin is the array of radio telescopes here in the UK, from Jodrell Bank down to Cambridge and Worcestershire and a few other places besides. Now, they're all looking at radio waves, and one of the advantages of using an array of telescopes, they're linked now with optical fibres that gets an even better sensitivity than it had before when it was just Merlin. Now it's E. Merlin. And because they're 220 kilometres apart at their widest, when used in the right way, in principle, you get observations with the resolution of a telescope that is 220 kilometres across. So incredibly high resolution images. Now, what it's done is its first light image is it's looked at the double quasar. Now, quasar is a very bright galaxy in a distant universe, more than 10 billion light years away. And we can see coming out of one of the images, we can see this jet of very energetic particles shooting out for further than the Milky Way is wide. It's an incredibly long jet of particles.
Well, we have some other news that have just come in.
On Saturn's moon Titan, the Cassini spacecraft has possibly spotted a cryovolcano for the first time. We were talking about these icy volcanoes earlier in the programme, but this is the first time we've seen one on Titan. In this radar image, which sees through Titan's thick clouds, a mountain, a crater, and possibly even the equivalent of a lava flow can be seen. The material spewing out isn't molten lava, but could be slushy, methane-rich water with a consistency similar to soft candle wax.
Chris, thank you very much. Don't forget our webpage. People find that very useful. It's bbc.co.uk/Sky at Night. And when I come back next month, I'll be talking about that lovely constellation of Orion. So until then, good night.
And there's more celestial activity over on BBC Two now with stargazing. Coming up here on BBC4 though, stay with us for breathtaking art with Baroque next.